Hi, have you ever wondered how scientists can calculate how fast rocket is rising into the sky? Or how economists predict how quickly prices will change? The answer lies in a powerful mathematical idea called derivative. A derivative measures how something is changing at a specific moment in time. For example, when you're driving a car, the speedometer shows how fast you're going right now. That's a real-life example of a derivative, showing how your distance is changing over time. Derivatives helps us zoom in on change, whether it's how fast a rocket climbs, how a population grows, or how company profits increase. They use in physics, engineering, biology, economics, and many other fields. In simple terms, derivatives help us understand and predict the changes happening all around us, making them one of the most useful tools in mathematics.
So now, I will be discussing about chain rule. So ano nga ba yung chain rule? Chain rule is isa sa mga shortcut in solving derivatives. So ito yung formula ng chain rule. F prime of x is equals to n inside function raised to n minus 1 times the derivative of inside function. So tuwing kailan nga ba ginagamit ang chain rule? Ginagamit yung chain rule kapag yung given is naka-enclose yung smaller function sa larger function. For example, is quantity of 3x plus 5 raised to 9. So, solve natin. F prime of x is equals to n. The n natin is 9, which is yung ating exponent. 9 times inside function is 3x plus 5. 3x plus 5 raised to n, which is yung 9, minus 1 times the derivative of inside function. Ano nga ba yung derivative nito? Which is 3. So, let's simplify. 9 times 3 is 27. Then 3x plus 5, 9 minus 1 is 8. So yan na yung pinaka-simplest form ng answer, and that is the chain rule. So hi, ngayon naman tuturo ko kung paano mag-solve ng derivative using logarithmic. So ito yung formula ng logarithmic. D over dx log base IA, tapos nasa loob yung u, is equals to u prime over u ln of a. So yan yung formula. So here yung example. Example is f of x is equals to log 3 tapos x squared. So, anong una mong gagawin? Ano mong gagawin is kukunin mo yung a mo, yung u, and yung u prime. So, ano ba yung a mo? A mo is ito. So, ano yung a mo? 3. Then, yung u mo is ito, x squared. And then, yung u prime mo is, kukunin mo lang yung derivative neto, which is 2x. So, paano naging 2x? Dahil x squared, ibababa mo yung 2 here, bali magiging 2, then minus 1. E di magiging 2x raised to 1. So, dahil nga 1, hindi nilagay yung 1.
In conclusion,
So, next,
just remember the quotient rule is perfect for when you're taking the derivative of one function divided by another.
equals to
Just apply the formula, simplify, and you're good to go.
x over u x squared ln a. So, ln, ano yung a mo? 3. So, yan na yung derivatives using logarithmic. So, noon naman, tuturo ko is how to solve derivatives using exponential. So, here yung formula. Derivatives of e raised to u yan is equals to e raised to u times u prime. So, example, f of x is equals to e raised to x raised to 7. So, yan yung example. So, anong una mong gagawin? Ito daw, f prime of x is equals to e raised to u. So, ano nga ba yun? Magiging e raised to x raised to 7 times u prime. So, i-derivative mo lang tong x raised to 7. Magiging 7x raised to 6. Paano siya naging 7x raised to 6? Diba? X raised to 7, ibababa mo yung 7. Tapos, 7 minus 1 is equals to 6. So, yan. 7x raised to 6. So, ngayon, multiply natin sila. So, yung f prime of x mo raw is magiging 7x raised to 6 x raised to 7. So, yan na yung derivatives nito using exponential. Okay, now naman, tuturo ko sa inyo paano mag-solve ng derivative using trigonometric. So, dahil nga marami ikakabisado sa trigonometric, gagamit na lang tayo ng trick, which is yung SC. So, ganito, suot mo siya ng paikot. SC. Ito, negative. Then ito, negative. Tapos dito sa tabi ng S, lagyan mo ng cotangent, negative cosecant, and cosecant. Here naman, sa tabi ng negative C, lagyan mo ng tangent, secant, and secant. So, paano mo ito gagamitin? So, ito na yung example. F of x is equals to cosine 5x. So, ito yung cosine, ito yung angle. Yan. Then, anong gagawin mo? Una mong gagawin is, i-derivative mo tong nasa labas, which is yung cosine. So, paano mo siya i-derivative? Tignan mo kung asan siya dito sa ating pabilog. Then, kasi ganito yung ikot niya. Yan. So, dahil nga cosine siya, positive cosine, ang kasunod niya is negative sine. So, magiging, yan na. F prime of x is magiging equals to negative sine. Tapos, ikakopy mo muna yung angle, which is yung 5x. Tapos, i-derivative mo ngayon yung angle. Ano ba yung derivative ng 5x? Yun ay yung 5 times 5. Now, solve natin. Bali, f prime of x is equals to negative sine times 5, magiging negative 5 sine of yan, 5x. So, yan na yung answer mo. Yan na yung derivatives using trigonometric.
Good day everyone, my name is Ariana, and now we're going to talk about the geometrical interpretation of the derivatives. This image shows the function as a curve. Imagine a function f of x is drawn as a curve on the xy plane. Each value of x gives a height f of x, so the graph of the function is a set of point or x and f of x. The slope between 2 points or the second line. Point A is equivalent to x, and f of x, while point B is x plus h or f of x plus h. And the slope of the line connecting these 2 points is the slope of the second line. The slope of the second line is derived as f of x plus h minus f of x all over h. That is called the difference quotient. Now, imagine sliding point B closer to point A by making h smaller and smaller. For example, h approaches 0. The second line rotates and becomes a better approximation of the curve at point A. As h approaches 0, the second line becomes now the tangent line to the curve at point x, and the slope becomes f prime of x equals the limit of f of x plus h minus f of x all over h as h approaches 0. So, geometrically, the derivative f prime of x is the slope of the tangent line to the curve at the point x and f of x. Let's now proceed to what the slope tells us. If f prime of x is greater than 0, the graph is increasing at x, or it's going uphill. However, if f prime of x is less than 0, the graph is decreasing at x, or it is going downhill. And lastly, if f prime of x is equals to 0, the graph is flat at x, possible peak, valley, or inflection point. Now, for optional visualization, imagine zooming in on a smooth curve at point x. The more you zoom in, the more the curve looks like a straight line. That line you're seeing is the tangent line, and its slope is the derivative.
So now, we will discuss naman on how to get the derivative of a function using the power rule. This is actually one of the most basic rule. Power rule is used to differentiate algebraic expression of the form xn, where n is a real number. In this rule, we have the formula of d over dx of x raised to n. We have the variable, which is the x, and we also have the exponent, which is the n naman. So to get the derivative, we will multiply the exponent sa ating magiging coefficient, then right after, sa exponent naman, or sa n, ay we will subtract 1. So now, we'll try to solve for some examples. So we have the derivative of x raised to 2. So to solve that, we have x raised to 2, and the exponent, or the 2, will go to the front and will serve as our coefficient. So it will result as 2, and then copy x, and then as I've said, the exponent minus 1, so it will become 2 minus 1. So now we have 2x raised to 2 minus 1. It's equals to copy 2x, and then 2 minus 1 is equals to 1, and 2x raised to 1 is also equals to just 2x, and that's the final answer. So now let's try a different example. We have here the rational example. We have the derivative of 1 over x raised to 2. And to solve for that, we first have to rewrite it. So we have the derivative and move the variable or the x squared to the top. So we will have the derivative of x raised to negative 2. And now we have the derivative of x raised to negative 2. With that, we can now solve it using the formula of x raised to n. So now, we have x raised to negative 2. And then the negative 2 will serve as our coefficient that will equals to negative 2, copy x, and the exponent, or the negative 2 minus 1. So now we have negative 2x raised to negative 2 minus 1. So copy negative 2x, and then negative 2 minus 1 is equals to negative 3. And now we have negative 2x raised to negative 3. and then the variable x raised to negative 3, we can put it at the bottom, and then the negative 2 will remain on top. So now we have negative 2 on top. And we all know that x raised to negative 3, if you put it at the bottom, it will become x raised to positive 3. And then we can write it as negative 2 over x raised to 3, and that's the final answer. Another example would be the derivative of square root of x. Using the power rule, we can rewrite it as derivative of, we all know that the square root of x is also equals to x raised to 1 half. And now we have the derivative of x raised to 1 half. With that, we can now solve for the answer using the formula x raised to n. And we have 1 half multiplied by x raised to 1 half. We now have 1 over 2 multiplied by x raised to 1 half. And think of a number that is also 1 half, which is 2 over 2. So now we can write it as 1 over 2 multiplied by x, and then 1 half minus 2 over 2 is equals to negative 1 half. So now we can write it as 1 over 2 multiplied by x raised to negative 1 half. 1 and the variable x raised to negative 1 half will remain on top. So now we can write it as 1x raised to negative 1 half over 2. So now we have x as our numerator and then 2 at the bottom together with the positive 1 half. So x over 2 raised to positive 1 half is also equals to x over 2 to square root of x.
Now let's delve into another fundamental rules in calculus, which are the sum and difference rules. So in this case, they're basically the same but with different operations. So these are the building blocks for more complex derivatives. So let's master them together. Let's start off with the sum rule. So in sum rule, basically if you have two functions which are f of x and g of x, the sum of their derivatives is simply the sum of their derivatives. Mathematically, you will have derivative. So derivative is denoted by d over d of x. d of x, f of x, plus g of x. Or is equals to f prime plus g prime. So let's illustrate it with example now. Suppose f of x is equals to x squared and g of x is equals to 3x. So let's get the derivative of f of x. So the derivative of x squared is basically using the power rule. So let's get it. That's the 2. We write x and 2 minus 1 is equals to 2x raised to 1. Or let's remove the 1. Next, let's get the derivative of g of x. So g of x is equals to 3 using the constant rule. Therefore, the derivative of f of x plus g of x is equals to 2x plus 3. Now let's move on into the difference rule, which is very similar. So in here, the derivative of the difference between two functions is the difference of their derivatives. In short, it is the same with the sum rule but with different operation, which is subtraction. So to write that, we have two functions, f of x and g of x. So the derivative
of f of x minus g of x is equals to f prime minus g prime. So let me give you an example. Let's use the previous example, which is x squared and gx is equals to 3x. In here, you're going to again first find each of their derivatives. So for the f prime, you're going to use the power rule to get the derivative of x squared. So x squared is equals to 2, rewrite 2, write x, and then 2 minus 1. Simplify, it's 2x raised to 1, or just, and then next you're going to take the derivative of 3x using the constant rule. So you're going to get 3. Now using the formula once again, the derivative of f of x minus g of x is equals to f prime, which is 2x minus 3. And that's how you get derivatives using the difference rule. Now let's look at the constant rule. So in constant rule, you just have to remember one rule, which is that the derivative of a constant is equals to 0. Meaning, as long as it is a constant, its derivative will always equal to 0. For example, the derivative of 1 is equals to 0. The derivative of 100 is equals to 0. No matter how big or how small the number is, as long as it is a constant, its derivative will always equals to 0 if it doesn't have any variables attached to it.
Hi everyone, I'm Faith, and today we're going to talk about the product rule. One way I like to remember it is by thinking of f of x is the first function and g of x is the second function. So when we apply the product rule, the right hand side becomes the first function times the derivative of the second plus the second function times the derivative of the first. Let's first start labeling our functions. So here are the first function and here are the second function. Let's take the derivative of our function. So we have f prime of x is equal to the first function, so 3x squared plus 2 times the derivative of the second function, which is the derivative of the x to the fifth minus 2x. So that gives us 5x to the fourth minus 2, then plus the second function, so we have the x to the fifth minus 2x times the derivative of the first, so the derivative of the first is equal to 6x. Okay, and so from here, let's go ahead and expand our terms so we can simplify. So we have 3x squared times 5x to the fourth, which is 15x to the sixth. 3x squared times negative 2 is equal to negative 6x squared. And then we have plus 10x to the fourth minus 4 and 6x to the sixth minus 12x squared. The next step is to combine like terms. So we have an x to the sixth here and then x to the sixth here. You have an x squared term here and an x squared term here. And we have an x to the fourth term here and the minus 4 here. So let's go ahead and combine our like terms. So we have 15x to the 6th plus x to the 6th. So that gives us 21x to the 6th. Then we also have our 10x to the 4th And then we also have our minus 6x squared and our minus 12x. So we can go ahead and combine those two. And we get minus 18x squared and we have our minus 4. And so that is our derivative.
Today, we're going to tackle about the important rule in calculus called the quotient rule. This rule helps us to find the derivative of a function that is written as a quotient or a fraction. That means one function divided by another. The question is, what is the quotient rule? If you have two functions, let's say f of x is the top function that is called numerator, then g of x is the bottom function that is called denominator. Then the derivative of their quotient, written as f of x over g of x, is given by this formula. There, the derivative of f of x over g of x is equal to f prime times g minus g prime times f over g squared. So here's an example. X squared over x plus 1. Let's first identify the f of x and g of x. The f of x is equal to x squared and g of x is x plus 1. The next one that we'll identify is the f prime and g prime. The derivative of x squared is 2x because of the power rule. Then the g prime is 1. The next step is, let's plug into the quotient rule, written by this formula. There. Let's apply the given function. The derivative of x squared over x plus 1 is equal to 2x times x plus 1 minus 1 times x squared over x plus 1 squared. So let's now simplify it. 2x times x is equal to 2x squared. Then 2x times 1 is equal to 2x. Then minus 1 times x squared is equal to x squared over x plus 1 squared. For the final answer, let's now subtract 2x squared and x squared. That is equal to x squared. Plus 2x over x plus 1. Now, that is the final answer for our derivative of x squared over x plus 1.
We started by learning what a derivative is. Basically, it tells us how something is changing at a specific moment. For example, speed is the derivative of distance with respect to time. Visually, we use a secant and tangent line to see how derivative describe a curve's behavior at a single point, kind of like zooming in to see what's really going on. Then we learned some key rules that make calculating derivatives much easier, like the power rule, constant rule, and the sum, difference, and constant multiply rules. After that, we move on the product and quotient rules, which are super helpful when you're dealing with functions that are multiplied or divided. Want to go further? Check out resources like Khan Academy or Paul's online math notes. They're great for extra practice. Now it's your turn. Grab a pencil and start practicing. The more you work with derivatives, the more they'll make sense, and the more you'll see how powerful they are in math, science, and beyond.